Hi, my name is Eric Dorsey, and I will be presenting my course project for Dr. Zhu's Computer Integrated Manufacturing course at Lamar University from the College of Engineering. Here I have just a brief outline of the things that we're going to be going over in this project. We're going to open it up with the introduction, and then we're going to speak about the project objections and the requirements, the original design description, the original design assembly, the improved design and assembly, the manufacturing plan for one of the parts that are in the approved design, and then we're going to look at the design for assembly analysis, and then we're going to sum it up at the end. The product assembly had to have at least 6 different parts. We had to design the original part using Creo 3D software, and redesign and improve product assembly using Creo as well. We had to develop and generate the manufacturing process for one of the parts. So my product selection was, I chose to redesign a coupling guard. I chose to redesign a coupling guard because I've been working in rotating equipment for going on 10 years, and I've seen a lot of coupling guards, and some of them made good sense and some of them not so much. So my goal is to reduce the amount of parts while increasing the product range that the coupling guard can be used on. I wanted to increase the assembly time. I want to eliminate the need for the reaching and around and the walking around to assemble the product on a machine. I would like to decrease the tools needed, but one of the hard constraints is that I need to make sure that the coupling guard is still OSHA compliant. So what is a coupling guard? As you can see here on the bottom of this slide, we have 2 pump skids. Both are pumps driven by motors on a skid, and both have coupling guards. Both are OSHA, both are different. One is bolted down to the skid and the other one is bolted to the actual pump. So coupling guards are used to protect the user from the rotating shaft of the motor and the pump. They're used in a variety of applications and have all different kind of standards. One of the standards that must be kept in this design is that the coupling guard must remain OSHA compliant. It must remain OSHA compliant because a lot of manufacturing facilities, a lot of plants require that their guards be OSHA. What is OSHA and what does that mean for this project? Occupational Safety and Health Administration is what OSHA stands for. And what they do is they ensure the safe and healthful working conditions of the workers. Per OSHA guidelines, the coupling guard must be attached to the machine or secured to an area where the worker will be in contact with the machine. It must be manufactured in a way that it protects the operator's body parts, free of sharp edges, must not be able to reach hazard by reaching over, under, or around, or through the guard. You can't stick your fingers in it. You must not be able to stick a tool in it while the machine is operating. It must provide visibility to the coupling. The guard should be installed in such a way that tools are necessary for the adjustment or removal. So some of the examples of some fasteners that can't be used are slotted or Phillips head screwdrivers, wing nuts, magnets, latches and haps, hooks and eyes. This is just an added design challenge that made it just a little bit more difficult to try to eliminate some of the fasteners that are being used on the old design. So here's what the old design looks like. As you can see, it has quite a lot of parts. And you'll see that next slide in the exploded view, but just some key points that I want to highlight on this. It's made out of steel. It is OSHA compliant. It consists of 12 parts. It requires welding. As you can see here, it requires welding to weld this plate to this cover, and also these nuts inside of this bracket. and it needs a total of 12 bolts. That's a lot of fastening. So here we are, we have the exploded view of the old design coupling guard. So we have two front halves, two half covers. These front halves get welded inside of these half covers. We have two expanded metal pieces. Each one of these pieces gets welded inside of this cover, and this is to allow for you to see the shafts rotating. It serves a purpose of checking rotation upon startup, but also just to see if the machine is running. You always want to be able to tell if the machine is running. We have square nuts here that are welded inside of this bracket, and then we have this rear bracket that will be welded inside here, and then there's a front plate that will be added into this bracket, bolted on, and you can see those listed out here, along with the bolts and the washers and the nuts. You'll need 6 bolts, 12 washers, and 6 nuts to put these two halves together, as you can see here. So here are some of the bombs kind of exploded up just a little bit more. All of these are made of steel, like I said. Here's the front half again, the half cover, the expanded. Here's a better picture of that filler plate. And here is the rear bracket, kind of brought up to the front a little bit more so you can see it with this rear wall that will be welded inside of here. So I really wanted to get rid of a lot of the welds and a lot of the fasteners that are needed. But the challenge was that the fasteners had to be OSHA compliant. So I couldn't use hooks, I couldn't use clasp, I couldn't use magnets. But that was a goal to get away from the fasteners. So this is what I came up with. So here I was able to keep it OSHA compliant, but it only consists of 7 parts. There's no welding needed, and it's highly adjustable. It can go from, I believe, 10 inches to 17 inches long. Here's a view of it exploded. So, excuse me. So we have the rear wall here, quantity 1. We have an outside cover here, the inside cover here, and it's designed to where this cover slips inside of this cover. The front wall, and then just 3 bolts, 6 washers, and 3 nuts. So that's a considerable decrease in parts. These rear plates and front plates, as you can see here, are made out with notches. And what these notches do, they allow for these covers to be slipped over these and fastened down around it at the bottom here, which eliminates the need for welding or screwing down these covers to these plates. And this rear wall plate will get attached to the pump. So that's really all of the bolting that you do is down here. When you finally get the covers on and adjust it to the length that you need it to be, you will bolt down the coupling guard. Here's the bolts and the nuts and the washers that you would use. And the part that I chose have the manufacturing plan written out for is this rear wall. But this rear wall will be made out of 12 gauge aluminum sheet metal. The first process will be just to mill out the 6 bolt holes at a 0.44 diameter on a pattern at 60 degrees around an 8.25 diameter circle. The next step will be to profile mill in the shape of the rear wall. It's that simple. So I just want to go over some of the design for assembly principles that were taken in consideration when redesigning this coupling guard. So the principles call for you to work to try to minimize the part count, design parts with self-locating features, design parts with self-fastening features, minimize reorientation of parts during assembly, design parts for retrieval, handling, and insertion, emphasize top-down assemblies. So we were able to, I can go back. We were able to design self-locating features. As you can see here, we have these tabs that go inside this hole here. We were able to design self-fastening features. We were able to design parts for insertion. So this part slides into this part slides into this part. Let's take a look at some more key principles. Want to standardize parts. We were able to minimize fasteners. The design for assembly principles encourage a modular design, and it's not they design for a base part to locate other components, and then design for component symmetry for insertion. Here, I was able to kind of give you a visualization of how the coupling should go together, and showing you how you can extend the coupling and how the rear wall and the front wall go inside of the coupling guard. So this part, that part that I'm moving right now, that's the rear wall, and that's the part that will be assembled on the pump. Next, you would install this coupling, and I'm moving back and forth just to show you the adjustability and how wide a range of product and shaft lengths that it could use. You slide that in there. It can be as long as I pulled it all the way out, or it can be as short as what I'm going to show you right now, which comes out to be 10 inches. So some of the improvements that were made, some of the bigger ones, is that I was able to eliminate a lot of the fasteners. There was no fasteners needed to mount the covers to the walls, which really improved the assembly process and assembly time. If you study assembly and you know what value added means to an assembly process, we know that fastening screws is not value added. to an assembly process. So the less fastening that you can do, the more efficient and the more value you add to your product assembly. I was also able to eliminate the reach factor. With the old design rear wall, when this was attached to the pump here, you had to reach around to attach it to the pump. No matter where you were, what side you were on, you were going to end up having to reach around and more than likely have to use an extension to get in there and fasten those bolts. With the new plate here on the right, it's flat, so there's no reaching. You don't have to reach around, you don't need an extension. You just need a socket wrench. So here's when we do our design for assembly analysis and just look into some of the things that we kind of outlined and we were aiming for when we went into this process trying to improve the process. So the the old design is OSHA compliant and the redesign is OSHA compliant as well. The adjustable lengths for the as is went from 10 inches to just 12.25 inches. So what that means is that if there was a pump configuration and a motor configuration where the both shaft lengths and the coupling lengths were more than 12.25, you will have to go to a different size. So with the new redesign being able to reach from 10 to 7.5 inches, you're able to use this product on a wider variety of machines. That way you're not only getting rid of part numbers and parts with this redesign, you're also eliminating other parts that will be needed for different sizes of pumps and packages. So with the old design, the as-is design, you have 12 parts total. With the redesign, you have 7. Now, we have 12 different parts for the old design, but with all of the quantities of those parts, of those 12 different parts, you end up with 53 parts, whereas the redesign only has 16. The old design needs welding, the new design does not. Secondary operations, as in twisting bolts, walking around the machine, checking this, leaning, reaching, fastening after you've already assembled a part or joined two parts. We have 12 different secondary operations for the as-is. For the redesign, we only have 3. The number of tools required for the as-is is 2. You need 2 different sockets to reach this, to use this, and you also need an extension. With the redesign, you only need 1 because there's only 1 bolt size. With the as-is, it'll take approximately 25 minutes to assemble. And that's not counting the primer and the paint that you're going to need to add to this after it's been assembled, because it's steel. With it being aluminum, as you assemble it, it's ready to go. And this is my project. Thank you.